Hi, and welcome to our webinar. I see a lot of people, so thank you very much for attending. I think we'll give a few more minutes so everybody could join. I see a lot of people are on time, which is brilliant. So let's wait a bit for a few more minutes. Yeah, and meanwhile, well, I see that not all of you are from Poland, so we have beautiful summer, pretty rainy today. I hope you enjoy your summer a bit more than we do here in Poland. So it's pretty, yeah, pretty unsummer, I would say. But yeah, that's what we have now. Okay, I see more people are joining us. Some familiar faces, some new faces. Very glad to see you all. Okay, maybe let's give one more minute and then we will start. Yeah, so as you can see, there are no video for you and no possibility to speak, but you will have a section for Q&A, and I will say a bit about it during the slides, but there is the Q&A session, so please feel free to, write the questions. We will have a Q&A at the very end, so all the Q&A that we will gather during the meeting, we will have at the very end of our webinar, so we'll be able to answer them. I believe most of them will be technical ones for Maciek, but of course, if you have other questions, I'm happy to support you, to assist. Okay, we have now 25 people. So I think we could start, slowly but surely from the beginning, let's say, and then move forward. So I hope you can see my screen. That's the most important part. I see that it is visible, so that's awesome. So maybe, some technicalities from the very beginning. Agenda, the same as it was mentioned at our invitation. So we will have company introduction, pretty short one, just, to be everybody at the same page. There will be smart mission ecosystem overview, again, very short one because it's related to another part of the webinar, which is Smart Mission Lab, remote access to our data processing units, and specifically Leopard data processing unit overview and the technical demo. And then, as mentioned, Q&A session. So you could write your questions during the whole webinar, but we'll speak about them and answer them at the very end. So let's start from the very beginning. I'm Helena Milevich, and I am head of product in KP Labs. With me today is Maciek. Maciek, will you introduce yourself?
Hello, everyone. I'm Maciej Nowak. I'm working as a software engineer in KP Labs, and I'm responsible for the Smart Mission Lab service that we'll show you today.
Yeah, thank you. I always say that Maciek is the soul and heart of the Smart Mission Lab. So most of the time he will speak today. And the more important thing is that we are recording. As you can see, we are recording the meeting. So if you have any other meetings in between after the webinar, we'll send you the recorded video. Of course, I hope you will stay with us until the end, because at the end we'll have the Q&A, which is pretty important, I believe, as you're here. So probably you want to learn something new, you want to ask, you want to see how the Leopard works, how the algorithm works. So I really encourage you to stay and interact and ask the questions. And I think I mentioned all the technicalities. So starting from the beginning, who we are. KP Labs is actually celebrating 9 years this summer, this July. Next year it will be 10 years. It's at the same time, it's very short time frame, but it's also very long when you work in the space industry day to day. So we are founded in Poland at the very south part of Poland, quite close to the Czechia, but we work internationally. Of course, the main focus is Europe, but we also cooperate with America, with Asia. So, as it looks in space industry, there are pretty much no borders. What we do as a company, we focus on onboard data processing. This is specifically our area. This is core of our business. And we work mostly with the, let's say, payloads, on the payload side. So what we do, we provide data processing units, embedded software and mission-specific software, and also algorithms for the specific, let's say, purposes. So far, we participated in 9 missions, actually in 10, and it's growing. At the moment, we have 85 people. We completed over 35 projects for European Space Agency, for the NASA, for the Canadian Space Agency with DLR. And I always say that I love to collect all the logos. So that's just my passion. Speaking about the technology pillars, so everything what we do on the project side and both on the product side, they are actually circling around these 3 areas. The first one is data processing payloads. Another one is flight software payloads and edge computing. Speaking about the data processing payload, these are the actual ecosystem, the end-to-end solution to bring this data processing on orbit to your mission. There is also the flight software payload, which could be embedded software for our data processing units, but it also could be mission-specific software. One of this example is a NASA mission. And there is also the edge computing, like a whole pipeline, but not to prolong. That's, let's say, the visualizations of mentioned above. We call it smart mission ecosystem, and that's the idea that everything works with everything. We have the Oryx, which is let's say animal of all the software that we do. There's also layer most, let's say, advanced, which is data processing units, antelope, leopard, lion. So we started with the smallest one, which is antelope. Leopard is a bit bigger, let's say, guy, and you also could see it flying in the ISS in the recent days because it was a part of the Ignis mission. It's still there on the ISS, although the Polish astronaut got back yesterday. And there is also Lion, which is still under development, but this is the biggest guy for the processing capabilities, and it's still waiting for the in-orbit demonstration. All the rest, it was tested in orbit. It's working in orbit, working pretty successfully. And then the very bottom is the Earth, and it's a bunch of different algorithms for the Earth observation, but also for the signal processing or like telemetry analysis. So the idea that we are covering the whole, let's say, pre-processing, processing, and post-processing chain, so you could get the best out of your data. And yeah, that's the physical, let's say, physical visualization of how the data processing units look like. You could see a difference. And these are the pictures. This is a good thing that this is pictures and of the real hardware. So you could see Antelope is the tiniest one. The idea that we use the combination of the CPU plus FPGA. There is the Leopard, a redundant and non-redundant version. It's a bit bigger guy. And Lion itself, which is using a bit different FPGA because it's Kintex, ultrascale, but still the same idea of processing and even making some data fusion in orbit for better decisions. And today we're focusing on the Leopard. So Smart Mission Lab, what's that? And why is the essence of today's webinar? So Smart Mission Lab is the idea is to allow remote access to our data processing unit. And, the thing that I'm focusing and I'm facing almost every day is the clients and partners, they're saying like, okay, but what are the effects? What are the effects of my algorithms, of my software? What results I can expect? What about the temperature range, et cetera, power consumption, all these beautiful questions. One, there is, to be honest, not a single answer because every mission is different. Each satellite is different, orbit is different, algorithm optimization is different, like everything is different. So there is no universal answer to this question. That's why we built the remote access to our data processing unit. And this is important because it's a physical hardware that is sitting in our server room, and you are connecting to it through the platform. And the platform is called Smart Mission Lab. So the idea that normally you have to purchase and wait, long months before you get something physical to test, either it's a test bed or the engineering model, you still have to wait long days, sometimes months or even years to get this precious piece of the hardware to check whether it works correctly or not, whether it fit your mission, et cetera, et cetera. So the idea that in case of Smart Mission Lab, we reverse the process. So we have the process of try before you buy. So you pay a fraction and then you get to the data processing unit. Okay, it is remotely, but still you could test a lot of things and you could understand. There is also the nice infographic of all the processes, how it went, etc., etc. And Maciek will show it in a bit. There is also, no need to make a huge investment upfront. If, for example, it's the project and the very beginning of the project or the very beginning of mission concept, you have to prepare all the things, but you're not sure what's the architecture is better, which algorithms, what could be performed. So that's also a nice way to kind of getting closer to the final results and understanding of how it will work. So maybe switching to the technical part, and of course, if you have any questions to what I already mentioned, please write them and I will get back to them. But I think we're at the moment where we could, from theory, go to the practice, to Maciek part. So Maciek, I spoke about Smart Mission Lab and all the beauty, but tell us more, like what we see here, how this, what are the magic behind the Smart Mission Lab and how it actually works?
Sure. So let's stay for a bit in the theory land for the moment. So you, as a hopefully future customer of the Smart Mission Lab, you are the person on the left on the screen, where you are connecting to Smart Mission Lab network through VPN connection. We are providing you with all the necessary configuration files. And once you connected to that network, you get your own isolated piece of network where you have access to machines we call EGSE hosts. You get access to one EGSE host per each subscription you have at the moment. And this is the machine that is responsible for controlling the actual board that you bought as part of the subscription. From there, you can control the power state of the board, or you can use one of the many development facilities that we provide, like Ethernet connection or JTAG or serial port to Leopard to watch what it does from the first line of codes in the bootloader. But from that machine, you can control the entire board. You can have one EGSE host for one Leopard and another for another Leopard, maybe in different configuration. Maybe some EGSE host for Antelope or any different DPU that we will add in the future. And on all of these subscriptions, you have nice development environment when you can just start to run some software or develop your own from scratch if that's what you want. And in the background, we are responsible for collecting the telemetry data from all these boards that are pushed to Grafana that you can use to review all this collected data and see what's happening with the boards while you're executing your algorithms or software. And let's leave the slides to go to practice.
Okay, so yeah, we are starting the most fascinating part.
Yeah. So I'm on the Smart Mission by Lab website, where you start with all the summary of what Helena already said, the flow of buying the subscription, and why it's nicer to use than waiting years for hardware. And for this demo, I'm going to buy Leopard. Have many instances there. Let's go with this one. And just like going through any kind of e-commerce, like buying books on Amazon or groceries, anything, very simple process. I want to buy this Leopard for 4 months. I have all my data, billing data filled in as I'm already logged in the system. Then one click away, and I need to then move to the payment panel. This is our test environment, so I can use this pretty easy to remember credit card number, but it's just a test credit card that will not work on any other website, but it allows me to go through the payment. And in a few clicks, I'm back in the user panel, where I can see that I have subscription for this new Leopard. And we aim to provide you access to your subscription within 2 working days, hopefully a lot faster in most of the cases. But like 2 working days is the top limit of the time. And I assume that you don't want to spend next 48 hours on this webinar. So I already have subscription prepared for today. And I can see that the subscription is active, and there is a name where I have to connect to get access to this EGSC host I mentioned. But as I said, to get access to that Smart Mission Lab network, I need to download the VPN configuration file. It's a typical OpenVPN configuration that I can import to my OpenVPN client and connect, which I'm doing on my second screen right now. Linked a bit too fast. Yeah, if you're familiar with OpenVPN, then you need you know that this is a happy screen when everything is connected correctly. And the next thing I have to do is to just grab this name, and I can connect using SSH to that machine. You may notice that it didn't ask me for password, so we are using SSH public key authentication. So you're uploading your key to the website exactly like you do with GitHub or GitLab. And after logging in, you see nice logo, and there are a few links that you may find useful. And let's start with the documentation website, which is available to you even if you don't have active subscriptions, so you can browse it even right now. And as a summary, you see the exact same graphic with the layout of all these network devices. Also, you'll get some description of all the services that you have access to through EGSC host and on Grafana. And what's important is you get also access to tutorials. And for Leopard, we have series of tutorials called Zero to Hero that allows you to start from absolute nothing and get some working machine learning algorithms running on Leopard, guiding you step by step by starting with Vivado configuration for the Zinc device, building Linux distribution using Yocto, and ending with running the inference on Leopard. Of course, if you don't want to go through all these steps, as they can take few hours to complete, we are providing you with like binary files for each step. And for today, I'm going to jump to the right the end of the tutorials. So running the inference on DPU. And I'm already connected to the machine here. And as you can see, I have Linux image files prepared here. So like kernel, stuff like that. And I have few images to process. And these images, I think that if you're familiar with the deep globe dataset, you will recognize the patches from the bigger images. These images are already pre-processed and converted into small patches that will match the model input. But preparing the pre-processing of data and preparing the model is a topic for a whole another webinar. So what I'm going to do right now is just go through all this tutorial to the end and show you how inference is running on Leopard. I'm just going to open the second connection, and in this connection, I'm going to open the serial connection to Leopard so I can observe the boot process. It's like one of the things that we are taking care for you. You don't have to mess with like FTDI converters to connect to Leopard. Everything is given to you with nice names. There is a Smart Mission Lab command line utility that allows you to control your board, and it follows the same flow of commands that you would have to execute from the perspective of the spacecraft when Leopard is integrated in a larger system. And in case in Leopard, that means that powering on the processing node is a two-step process. So first we need to power on the Leopard itself. Then we can issue the command to supervisor to start the specific processing node. Of course, you don't have to write rough bytes on canvas to control the supervisor. We are giving you a nice command for everything. And in a few seconds, we will see that Leopard is starting. And in a moment, we will see the bootloader running. And it will use another nice facility of EGSC host that it is downloading the entire Linux image from the network. You have a dedicated network between your EGSC host and Leopard. So you can quickly iterate on your Linux image, add new software, customize settings without need to lengthy process of writing to persistent memories. So which gives you a very nice development environment. So we have Leopard up and running. So the next thing we need to do is to copy the input images to processing node, and then we can log into our Leopard. And our demo will use the deep learning processor unit IP core from AMD to accelerate the ground segmentation algorithm. Building of that IP core is part of the tutorials, so you can do it yourself. You can tune your settings if you want to try something a bit different. Also, preparation of model for this demo is also part of the tutorial, so you can go through that and build your own model from scratch or tune some settings in the middle. So let's start by loading the deep learning processor unit bitstream into the programmable logic part of the Zinc device. We see that it was loaded successfully. Then I can run a Python script for running the segmentation. The script also is written step by step in the tutorial, so you can understand what is going on in the process and how it interacts with the DPU. There are only 3 images to process, so it was quite fast. And we can quickly check if there are some results. Yeah, we have 6 output files, 2 files for each input. One is a JPEG file with overlaid results of segmentation, and also the NumPy file with like rough output data from the model that you can use to run some further analysis on the results and assess how your model is performing. There is no visual output from Leopard, unluckily for us. So I need to copy these images back to our eGSE host. And from there, I can use the built-in HTTP server from eGSE host to review the output files. I will just show on the split screen the preview, the expected outputs. Start with this one. Yeah, we see that we have pretty much the same output as in tutorials. Yeah, this one down here, and last one is this one. Yeah, so we got the same result just by running the steps from the tutorial. And I'm using the binary files that we are giving you to, so you can just buy a subscription and run it in essentially a few minutes after getting access to subscription.
Yeah, and just maybe one thing to mention is that, well, this time Maciek ran the algorithm. It is pretty much close to the one in the tutorial, but when we were testing, the algorithm beforehand, there were some little differences. So just to let you know that these are the real, implementation of the algorithms. So you can expect each time it will be exactly the same as in the tutorial, but it will be extremely close. So yeah, this time you have to trust us that it was live running. But if you test it yourself, you might see tiny differences, and this is the correct outcome also.
Yeah, especially if you go through the machine learning tutorials, that then you can have small differences in the model during the quantization phase that will result in small differences in the images. But that's also a thing that you want to verify with your process, that you can replicate the results. And speaking of results, and in the background, Smart Mission Lab was collecting telemetry data from Leopard. Let's switch it to 15 minutes. So this is a very simple dashboard that I built for this webinar. It shows like few astronautic characteristics, like some power outputs and currents. And you can see the difference in power control that I mentioned earlier. So everything is powered on, off, then we are powering on the supervisor. And after a moment, we are powering on the processing node. So you can, so you are getting familiar with the interface of the Leopard. So you are not, so it will be easier for you to integrate it later in the spacecraft.
But it's also worth mentioning that that's the way how it works on the spacecraft, that there is the supervisor, there is 1 or 2 processing nodes, and that's, let's say, shows how it will work on the spacecraft too.
Yeah, exactly. And you can verify that and learn how it works without waiting for hardware to get on your desk. Of course, if you want to see everything, we are providing you also with dashboard, that's predefined dashboard that shows pretty much everything. This is the same telemetry data that you will be able to receive on the spacecraft side, so you know what values you can, what types of values you can expect and how to interpret them. So it's easier to, so we're getting familiar with the actual flight model of Leopard while playing with Smart Mission Lab. And of course, you can define as many dashboards as you want. You can compare the telemetry data across different Leopards, through different boards. If you will get back to Leopard, to Smart Mission Lab after a while, you will still have access to your historical data, so you can just explore the data and things that are happening inside the DPU.
Yeah, and I think another thing that is also, you could actually run the algorithm, do some optimization, rerun it again, and compare the results of like what's the difference in the telemetry. Or in other case, for example, you have some target, let's say, numbers for your mission or for a project, and thanks to this, access to all the telemetry, you could also map it and see, and then plan, for example, what you have to do to adapt it to your target, let's say, numbers.
Exactly.
Okay. Do we have anything else you want to show us?
I don't think so. So okay. I think I can give the screen back to you.
Yeah, just one thing about the documentation. I think we didn't mention it, but what's important is that it's you don't need to register on the website to go through it. So it's open to everybody. You could go and see in very details how it works and what are the possibilities of it, what are all the little details that you can do or you cannot do. But the system, of course, because it's remote access, you might still need some data. So if you have any additional questions, whether this or that is possible and it's not answered directly in the guide, please do let us know, contact with us. Yeah, this is very nice, very detailed documentation. And actually, as you could see, Maciek walked us through, all the steps from the very beginning, and you could also understand the logic behind it and create your own, let's say, step-by-step scenario for the project, for the mission, to see what's the best results. Yeah, that's exactly a lot of details, a lot of technical details, how to power on the supervisor, the processing nodes, all the beautiful details. And what's great is that it is a flight hardware. It's an engineering models sitting in our server, so you will get very similar results in the real environment in the on the spacecraft. Of course, it depends on the mission architecture, etc., but this is, let's say, the range of what you can expect. Okay, I think we mentioned everything from the, let's say, must-have part. And okay, we have so far one question that is waiting, but of course you're very, very welcome to ask more questions. So maybe I will start with my question. My favorite one is what are the security, maybe not, well, as a client, I might have a security concern. So if you can explain, like, can I be sure that my algorithms and my data will stay with me and won't be available to everybody? Like, could you also explain it so we could also move on to another question?
Okay, so in terms of security, your slice of the Smart Mission Lab network is isolated and it's just for you. So only you have, while your subscription is valid, only you have access to your eGST host, only you have access to board connected to that eGST host. You can freely move the data between eGST hosts, but only eGST hosts that you are currently subscribed to. No one else, no other customer has access to your machine at the same time. And when your subscription is over, we are taking all the hardware that you used, and we are running cryptographically secure erase on all persistent storage there. So if you left any scraps of your IP or your models, we will remove it for you before giving that hardware to another customer. So like there's no way for any kind of data to flow between customers.
Mm-hmm. Okay, perfect. Yeah, it's very, very important to remember that at the end of your subscription, it's better to save all the files, all the results. So it's it's better for you. Okay, we have the questions are coming, and I encourage you to ask questions because it's a possibility to talk and to ask Maciek directly. So the first question is, what is the sequence of actions to get image or instrument data? Do I call APIs or schedule an observation activity?
Okay, so in Smart Mission Lab, there is no physical camera attached to Leopard. So you need to provide your own way to provide the input data. This can be for example, the uploading the JPEG file using let's say SFTP, or you can build some IP core that will simulate your camera and provide the data to rest of the processing pipeline. That's totally up to you how you can handle it. And with API, it's actually interesting thing. I was using the developer-friendly SSH connection to Leopard or serial port, so I can just directly input all commands. But also, but you will probably not do that in terms of when Leopard is flying in a satellite. In like real environment, you will have to use one of the APIs that is exposed by the Leopard to run some jobs. There is a functionality called job runner. And also through SML, you can access this job runner and schedule jobs on Leopard like you would do on the final spacecraft, giving a possibility to play with the learn the real life environment, an interface that you will have to use later, so you can like accommodate it in your operations plans.
Okay, thank you. Yeah, so basically, if you have any data sets you want to run your algorithms on, whether it will be, signal processing or image processing, you're very welcome to bring your own data sets and run your algorithms on them. But we have another question. Is it possible to perform an update to a Yocto-generated Linux image on a target device and successfully run the updated system?
Yes. I was using Linux image loaded from the network, but these are just files in my GST host file system. I can upload new files and my own generated Yocto image. Also, you can access all the boot modes for boot images. Let's call as it's called in the documentation for Leopard. For example, you can store the actual image in one of the persistent memories on Leopard, then use it to boot your DPU. You can just like you would do on the spacecraft, and you can just also try to update this image and update it again, exactly as you would do on the spacecraft. You can even access the boot flash memory for Zinc device and play with the bootloader and customize it if you want. Also going through the Smart Mission Lab command line utility.
Okay, perfect. And one more question. Does Smart Mission Lab support comprehensive hardware debugging capabilities across all supported hardware platforms?
Smart Mission Lab provides you with the JTAG access to Zinc ultrascale in Leopard or in other envelope. It's also ultrascale, any kind of DPU that will provide as part of Smart Mission Lab. You will have JTAG level debug access to Smart Mission Lab. Due to licensing reason, you have to install the Vivado Lab Edition on your own, but we are also providing you with a tool that will automate the installation. And you can run the HW server on EJC host, connect to debug probe, and even connect to that device from your local Vivado or your local debugger frontend to assess what is going on in the hardware.
Okay, I see there is one more new question, but it's uploading, so we'll have to wait. But in between, I will have my own question. So now we're speaking about the Smart Mission Lab, but there is also question that might, arise is if I buy physical Leopard, can you tell us whether it's bare metal, like what's the state of the hardware that I'm getting as a customer? If it's bare metal, is there some software setting? How it gets to my hand as a client, as a physical hardware?
I'm not 100% associated with delivering the final Leopard pieces of hardware. But from the software point of view, you get you can plug in Leopard to power, start it, and it will show you something. It will be very similar to like earlier stages of this tutorial. So you get like bare Linux where you can play with something, just verify that that is working. But we are the supervisor software is software that we are keeping to ourselves. But you are getting Yocto layers for all kind of software that runs on the processing nodes. Then you get the binary releases, so you can try something verified by us and something that works for sure. And also you get guides how to use layers and tools that we provide to recreate your own image and tune it to your needs.
Yeah, thank you. That's exactly was my question, like not from the hardware perspective, but the software. Exactly, you're not getting a bare metal, Leopard, but there is already sitting software, so you could pretty much start working instantly. And what's the beauty? The software that you use on Leopard through the Smart Mission Lab and the software that you're getting with the Leopard, with the physical one, and in general, the architecture, the logic, like the everything, the way you work with the Smart Mission Lab and the physical hardware is pretty much the same. So that's the beauty that you could start and verify your algorithms remotely. And then when you get your physical hardware, you could run them and you will see very similar results. So that's the smoothest part of this. Okay, we have 2 minutes and we have one more question. So if Leopard does not have a camera attached, understandably, are there any tools you can suggest to simulate such images that mimic acquisition on board a satellite? Do we know the answer?
I don't know the precise answer. I think it will highly depend on your processing pipeline, and I would also say this stage of the development, because you are more focused on doing the processing of your image than maybe just uploading the JPEG files or RAW files will be enough for you to tune, for example, the model or use some FPGA acceleration of processing of that image. And just uploading files would be enough for that stage. If you would want to if you're at the stage when you're writing the IP core for actually capturing the image from camera, then I guess you would have to write build your own IP core that will fit some fake data to that camera capture IP core. I don't know if there is anything out of the box that will give you that. I'm not that familiar with FPGA development. I think that's the topic that we can ask around our FPGA guys, and maybe there is something that we could offer in the future as part of the Smart Mission Lab. That you will have some ready-made tool that allows you to fit some data.
Yeah, and I would also just add that if you have anything specific in mind, just contact us after the webinar. We work with some payload providers, and we already have some established relations. And we have team onboard data processing team dedicated to specifically to the implementation of algorithms and the whole processing chain to the satellite and flight, let's say flight architecture. So if you have anything specific in mind, just please contact me. Here you could see the contact details, just sales at kplabs.pl. I will be the person who will answer you. So just if there are any specific ideas, and of course to everybody who's present here, if you have any ideas, suggestions, you want to include subscription to the Smart Mission Lab to your project or mission, or if you also have some questions related to the topic of onboard data processing, if there is enough inquiries, we can hold another webinar dedicated mostly to the onboard data processing side, because it's not enough to train and develop the algorithms. It's also the in space missions, it's also important to know how to optimize them and bring to the spacecraft, to the architecture, where everything is pretty much limited. They have limited power, they have limited space, they have everything is limited. So if you're interested in it, just let us know. And as we are running out of time, thank you so much for being with us. Thank you so much for your activity, for your questions. I hope you enjoyed the webinar. I hope you found it interesting, and it brought you a better understanding of Leopard, of the Smart Mission Lab, and also how to work with us, how to cooperate with us. If you have any ideas, again, please contact me. I'm happy to talk to you. Of course, thank you, Maciek, for you and for highlighting all the details of the Smart Mission Lab. Of course, thanks for our marketing department who helped us to organize everything. Again, you will get the video recorded sometime after the webinar, probably in a few days. Depends how marketing department will get it all together. Thank you so much, guys, for being with us, and yeah, enjoy your day. Bye bye.
Thank you for attending. Bye.